Chapter 7 is all about simplifying expressions involving powers. However, there are a couple other terms that I want you to know about as well. First one is called a monomial, and that's going to be a number, a variable, or the product of a number and a variable. Basically, when we break down this word, we have mono is one of the root words, and for mono means one. All right, so we're talking about one single term. So that term could be a number like 23. Right? Or it could be a variable like w, or it could be the product of those two, like 23w, or 17x to the third, or anything like that. As long as there's just one term, involving a number and a variable. The next word I want to look at is a constant, and a constant is a special kind of monomial. It's a monomial that is only a number. All right, so 23, that's a constant, but w isn't, 23w isn't, and 17x to the third is not either. When we're talking about a constant, constant means stays the same. It doesn't vary, so it doesn't have any variables. So real quick, which of the following are monomials? Well, I got 4 of them here. And remember, monomials are going to be those things that only have one term to them. So a number like 100, that's a monomial. A variable like x, that's a monomial. When we have a variable to a power like h squared, that's a monomial as well. The only one that isn't is f plus 24 because there are 2 terms. Right? The thing that gives it away is that plus, or if there was a minus in there too. All right, so this one is not a monomial. The other thing, out of the other 3 that are monomials, this one is the special one that is a constant because it only has a number, doesn't have any variables. Okay, so back to the powers. When we're talking about a powers, this is kind of the form of what a power is going to look like. There's 2 pieces to it. The x down here has a special name that's called the base, and up top there will be a smaller number kind of raised up. That's what we call the power. All right? So we would say this is x raised to the power of n. Now we have seen these things before. Before we called them exponents. All right? Exponents and powers are the same thing. All right? And one thing to remember about x to the n is that what it means is repeated multiplication. That means I'm going to take the base and multiply it by itself over and over and over again. Right? This would be n times. So something like 3 to the 5th, that means 3 times 3 times 3 times 3 times 3. Notice how many 3's did I write down? 1, 2, 3, 4, 5 of them. So we take 3 and multiply it by itself 5 times. When we do that, what we get is 243. Now that's something that we were doing before, just calculating an exponent, the value of an exponent like that. But we want to get into dealing with the properties of how powers and exponents, how they interact with each other. Specifically, I want to look at what happens when we take the product of 2 powers, when we multiply 2 powers together. And what's special about this product, and what's special about these 2 powers, is that their bases are the same. So if we were to expand them, this 2 squared means 2 times 2. And this 2 to the 4th, well, that means we would multiply by 1, 2, 3, 4 of them. When we go back to simplifying it, if you take a look, 1, 2, 3, 4, 5, 6. All together, there are 6 2's there that are being multiplied together. So that is 2 to the 6th power. So back up a second and think, how do we get that 6? From what we started with, when we looked at the powers that we started with, we had 2 to the 2nd power times 2 to the 4th power, and we got 2 to the 6th power. Let's take a look at another example. How about when we have 4 to the third times 4 to the second? Can you guess what that's going to be? If we expand this product and look at 4 to the third, that's going to be 4 times 4 times 4. 3 times. Then when we have that 4 to the second power, right here, that's going to be 4 times 4. Putting it all together, 4 is being multiplied by itself over and over and over again. How many times? Well, I see 5 different 4s there, so that would be 4 to the 5th power. So think about it. How did we get from where we started to where we finished? What we started with was two exponents that had the same base, 4s, 4 to the third and 4 to the second. And what we ended up with was an exponent that had that same base. It was still a 4. So the base didn't change at all. What changed was the power, and we started with 4 to the third and 4 to the second. And those two got combined to make 4 to the 5th. Right, if you take a look, how do you make a 5 out of a 3 and 2? You add them together. How did you make a 6 out of a 2 and a 4? You add them together. From just those two examples, we can kind of come up with our own property that describes the product of powers. We have two exponents that have the same base, those same x's. What am I going to do with this m and this n? Well, our guess is we're probably just going to take whatever those two numbers are and add them together. And we could show that to be true like this. For x to the m, that means that we're going to take x and keep multiplying it by itself over and over and over again. How many times? Well, that's going to be m times. Then we're going to take x to the n. We're going to multiply that by x over and over and over again times itself. How many times? Well, that would be n times. Overall, from beginning to end, if I got m of them and n more of them, that would be m plus n times that x is being multiplied by itself. That's why the power over here is m plus n. So let's practice simplifying a couple of them. If I have n to the 5th times n to the 3rd, so we see that multiplication of two exponents that have the same base. So our answer is going to have that same base. But when we simplify, we got to put those two powers together. So with 5 and 3, we have to add, and we'll get n to the 8th. If we start with y squared times y to the 8th, keep the base the same, it's still going to be a y. And when it comes to these two powers, we need to add them together. 2 plus 8 is 10. Now this one looks a little bit trickier, but remember, what's happening in between these two sets of parentheses is multiplication. What's happening in between the 6 and the n is multiplication. What's happening between the 2 and the n is multiplication. So we have a bunch of multiplication that's happening. And one thing about multiplication is that order doesn't matter. You know, if you had 5 times 10 or 10 times 5, it doesn't matter. You get the same amount, 50. In this case, since everything's being multiplied together, I'm going to rearrange it. So I'm going to go 6 times 2. So I'll have those two coefficients, the two numbers together. And then I'll multiply by n to the 3rd times n to the 7th. So multiplying the 6 times 2, that makes 12. And for n to the 3rd times n to the 7th, we use that property where we keep the base the same and add the two powers together. 7 plus 3 is 10. Now this is simplified. Let's try one more. 3y to the 4th times 7y to the 4th. Right? Everything is multiplying again, so we can rearrange it as 3 times 7 times y to the 4th times y to the 4th. 3 times 7 is 21. And when we see that product, we're going to keep the base the same and add those two powers. 4 plus 4 is 8. So 21y to the 8th is simplified.